Welcome to this lesson on proving lines are parallel. Just as in previous lessons, you're going to want to either take a screenshot or write down some notes on these first couple of slides. This is just the basic information on how these converse rules work. The idea here, we'll talk about this first one and then you'll get the same idea from the remaining ones. The corresponding angles converse. If you can show that two corresponding angles are congruent, then the lines that they are attached to have to be parallel. So just like before when we knew the lines were parallel, that meant the corresponding angles were congruent. We can now do the converse of that. If the corresponding angles are congruent, then that implies the lines are parallel. And we're going to have the same rule on the next slide for alternate interior angles, alternate exterior angles, and consecutive interior angles. So slide 1, pause if you need to. Slide 2. Again, pause if you need to. I'm moving on. Okay, so what we want to do is take this picture and the given information, and the given information is going to be that angle 1 is congruent to angle 3. And we want to show that that means that line L and line M have to be parallel to each other. Well, what we do is we identify what angles 1 and 3 represent. So we have angle 1 right here, and angle 3 right here. And you can see that for this transversal running left to right, they're both above the transversal, and for the two lines that the transversal is intersecting, they're on the left side of M and the left side of L. So these angles are in the same corresponding location. They are corresponding angles. Since we're given that they are congruent to each other, then the corresponding angles postulate converse tells me that angles L and M lines L and M have to be parallel. So you can have converse of the corresponding angles postulate or corresponding angles postulate converse. Either one is fine. Here we want to look at angles 3 and 7. Now before we do anything, let's identify angles 3 and 7 so we know what we're even trying to show. Angle 3, angle 7. Again, if this is my transversal, the one going up and down, they're both left of the transversal, and for the two lines L and M, angle 3 is just below L, angle 7 is just below M. These are in the same corresponding location. These are corresponding angles. So I need to show, in order for L to be parallel to M, that angle 3 and 7 are congruent. Now what they've given me are two algebraic expressions for 3 and 7 and a value of x for 30. So I'm going to plug that value into each of these and see if those angles are not in fact congruent. So plugging in for 3, 4 times x, 4 times 30 minus 80 gives me 40 using the substitution property. I'll do the same thing for the measure of angle 7. And once again I get 40 degrees. So both angles are 40 degrees. Therefore, they're congruent to each other. They're equal to each other by the transitive property because they both equal 40. Both angles equal 40, so they're equal to each other by the transitive property, which means they are congruent by the definition of congruent angles. And therefore, those lines have to be parallel because our corresponding angles are congruent. So our corresponding angles postulate converse tells me that the lines L and M have to be parallel to each other. Pause the slide if you need to look at that a little closer. We'll move on now. So here we're again trying to show that two lines are parallel, in this case R and S, and we're basing that on angle 4 being congruent to angle 8. So here's our given information. We're going to identify those angles 4 and 8. Well, the left to right line is the transversal. 4 and 8 are on the exterior, and they're also on opposite sides of the transversal. 8's below the transversal, 4 is above the transversal. So these are alternate exterior angles. So we're going to try to show that they are congruent, and if they are congruent, then what we have is parallel lines. Well, we were lucky enough to be given that 4 and 8 are congruent. So our given was that those two angles are congruent. Those two angles are alternate exterior angles, and if alternate exterior angles are congruent, the lines are parallel. So R and S are parallel by the alternate exterior angles converse. Again, pause if you need to, otherwise we'll move on. Okay, looking at angles 2 and 3, and we want to show that R and S are parallel. Identify the angles. 2 and 3. 2 is here, 3 is here. So we've identified the two angles. Technically, I should mark that they're different. So 2 and 3 here. So because they are in the interior of these two lines, our transversals running left to right, so these two lines, 2 and 3, are in the interior, and they're both above the transversals. They're on the same side of the transversal. These are same side interior angles, also known as consecutive interior angles. Now, if the lines are going to be parallel, our consecutive interior angles theorem converse says that they have to sum to 180. They have to be supplementary. So what I need to show is that they are two numbers that add up to 180 based on x equaling 5. They've given me two algebraic expressions for the measures of 2 and 3. So we'll plug in 5 for x in each of those and see what we get. When we do angle 2, we get 58 degrees. And when we plug in 5 for x in angle 3, we get 122 degrees. Well, a little quick mental math is going to tell us they do add up to 180. That's what we wanted to see. So when we put them together, we get 180 degrees. And because they're consecutive interior angles that sum to 180 degrees, we know our lines are parallel because that's our rule. That is the consecutive interior angles theorem converse. Those lines are parallel because the two consecutive interior angles are supplementary. Again, pause if you need to. Here we're going to show that these two lines are parallel with angles 3 and 7. So identifying the angles, 3 here, 7 here. If these two lines are going to be parallel, R and S, again, identifying the angles, these two angles are in the interior between R and S, and they are on opposite sides of the transversal. 3 is above the transversal, 7 is below the transversal. These are alternate interior angles. For these two lines, R and S, to be parallel, the alternate interior angles have to be congruent. So I'm going to use the fact that x is 50, and I'm going to plug that in for my value of measure of angle 3, 2x, and my value of measure of angle 7, x plus 50, and see what I get. If I get the same answer for both, then they're congruent, and if they're congruent, the lines are parallel. So plugging in for the measure of angle 3, I get 100 degrees. 2 times 50 is 100. Plugging in for the measure of angle 7, I'm just taking 50 plus 50. I also get 100 degrees. So these two angles are the same. They're equal to each other, so they are congruent by the definition of congruent angles. And since they are alternate interior angles and they're congruent, the lines R and S are parallel by the alternate interior angles theorem converse. Again, pause the slide if you need to take a closer look at that. Otherwise, we're going to move on. Here I want to show, I'm given that L and M are parallel, and you can see that from the red arrow markings. I'm also told that angle 1 and angle 3 are congruent, so let's mark that real quick, just so we see all of our given information. Angle 1 and angle 3 are congruent. Now what I want to show is that lines P and R are parallel. So I need to have some relationship between them. The obvious relationship is if I can show that angle 2 and angle 3 are congruent, then what I have shown is alternate exterior angles are congruent, so lines P and R could then be parallel by the alternate exterior angles theorem converse. So I'm going to use that angle 2 as kind of my bridge between angle 1 and 3 being congruent in order to prove that lines P and R are parallel. Well, since L and M are parallel, I'll be able to show that angle 1 and angle 2 are congruent because they are corresponding angles. Lines are parallel, corresponding angles are congruent. Well, if 1 is congruent to 2 and 1 is also congruent to 3, then 2 is going to be congruent to 3 through the transitive property. But if 2 is congruent to 3 and they're alternate exterior angles, then I can say my lines are parallel. So that's how the proof is going to run. I wanted to give you an idea of where we're going with this. And we'll kind of go back and forth from the picture to the proof, but the proof is going to be on the next slide. So we were given, remember, that the lines were parallel. And We were given that angle 1 is congruent to angle 3. What we're going to do, though, is make a quick statement. Since the lines are parallel, we're going to talk about angles 1 and 2 first, since we know they have to be congruent because they're they're corresponding angles. So I start with the fact that lines L and M are parallel. That's my given. I'm going to make the statement that 1 and 2 are congruent by the corresponding angles theorem. Then I'm going to go back. Remember, my other given was that angle 1 is congruent to angle 3, right there. So I'm going to use that as my next statement. So that's going to be my third statement. So angle 1 is congruent to angle 3. That's given. Now, let's make sure we're clear on something so you're not getting bogged down by this. These two are interchangeable. It did not matter that I put angle 1 is congruent to angle 2 first. That doesn't matter. I could have made the statement that 1 is congruent to 3. My second given, I could have made that my second statement. It does not matter what order I put those in. Okay? I needed both pieces of information to make my jump. My jump is that because angle 2 is congruent to angle 1 and angle 3 is congruent to angle 1, so I have a common piece between both equations, angle 1. If both of those are equal to angle 1, then these two guys are congruent to each other. So 2 is congruent to 3, and that's where we're going with this. 2 is congruent to 3, and that's by the transitive property of congruence. Okay, now what we have to do is then go back and look at the picture to understand how important that was. So, going back to the picture, focusing on the fact that we now know that 2 is congruent to 3. 2 is congruent to 3, then what I've just shown is this angle and this angle, which are alternate exterior angles for lines P and R, are congruent. If the alternate exterior angles are congruent, the lines are then parallel. So we've just shown the lines to be parallel by the alternate exterior angles theorem converse. And there it is. Yeah, if you need to back up and look at that one more time so you have a full grasp of the picture versus the full proof that we've done, all we did was link the fact that the one set of lines were parallel. That meant that the corresponding angles were congruent. That allowed us to use the transitive property to show that the alternate exterior angles were congruent for the other set of lines that we were trying to prove to be parallel. Okay, here we have angle 1 and angle 4 being congruent, and angle 3 and angle 4 being supplementary. So we want to mark all of that. So 1 is congruent to 4. That's this angle and this angle. Now what that tells me immediately is that line L and line N are parallel because of alternate interior angles being congruent, so the alternate interior angles theorem converse. What I want to show is that lines L and M are parallel, so I want to show that M is also parallel to L. What I know is that 3 and 4 are supplementary. So whatever 4 is, unless it's 90 degrees, 3 is a different angle. And the two of these add up to 180 degrees. Okay? So between the two of them, they make 180 degrees. Now what I would like to show is a relationship between L and M. The only angles that have any sort of relationship that we've even talked about between L and M are 1 and 2. And those are consecutive interior angles. Well, if the lines are going to be parallel, then those consecutive interior angles have to be supplementary or also have to add up to 180. Now, we don't know they add up to 180 yet. That's what we have to show. Okay? We need to show that they add up to 180 degrees. That's what we're hoping to prove. So keeping that in mind, here's what the proof would look like. We start with the fact that 1 was congruent to 4 and that was given to us. We can now make the jump from that the angles are equal. So we're going from congruence to equality. Remember, that is always definition of congruent angles. Remember, it also works the same way. So this could have gone either direction and I would have used the definition of congruent angles. So if I'd started with statement here at 2 and I'd wanted to say, well, if those angles are equal, then that meant these angles are congruent, I would have justified it with definition of congruent angles. Or to go from congruence to they're equal to each other, I'd justify it with definition of congruent angles. So either direction I go with that, definition of congruent angles. Okay, the other given that I had was that angle 3 and angle 4 are supplementary. So all I'm doing is working off the given right now. Well, if they're supplementary, that means they add up to 180 degrees. So I'm going to make the statement that measure of angle 3 plus measure of angle 4 equals 180 degrees. And that's the definition of supplementary angles. So I've now used my given to establish all of this. Well, here's what I know. The measure of angle 1 and the measure of angle 4 are the same. So anywhere I see the measure of angle 4, I can plug in a measure of angle 1. Well, here's a measure of angle 4. So I'm going to plug in measure of angle 1 into the measure of angle 4. And that's where I have measure of angle 3 plus now measure of angle 1 equals 180. And of course I did that with substitution. Okay? From step 2 into step 4. Alright, now that I know that, I need to go back and look at my picture for just a second. So I'm going to remove all these markings. And remember this little relationship, and this is from chapter 2. These are called vertical angles, and remember we have a vertical angles theorem that was from section 2.6. You want to look back in your notes on that from section 2.6. The vertical angles theorem said that vertical angles are congruent. So that's the next statement I'm going to make, is that angle 2 is congruent to angle 3 by the vertical angles theorem. So going back, remember we had made a couple statements off of our givens, and then we made a substitution. Now I'm going to say that the angle 2 and the angle 3 are congruent by the vertical angles theorem. So that means their measures are equal. I can actually go ahead and make that jump using the vertical angles theorem as well. Now, what we should notice then is measure of angle 2 and measure of angle 3 are the same. So wherever I see measure of angle 3, I can plug in measure of angle 2. Well, I see the measure of angle 3 back here in step 5. So I'm going to plug in measure of angle 2 for it, which is going to give me a new statement that the measure of angle 2 plus the measure of angle 1 equals 180. And again, that was substitution. Well, remember what my goal here was. I wanted to show that 1 and 2 were supplementary, because if they were consecutive interior angles that added up to 180 degrees. And if you have that, you have parallel lines. Let's go back to the picture and make sure we understand that. Again, focusing on angles 1 and 2. Angle 1 and 2 now. These two angles right here, we wanted to show added up to 180 degrees, and they do. So our consecutive interior angles are supplementary. Therefore, lines L and line M have to be parallel, and that's what we were trying to prove. So going back to the proof, we'll make that final statement that the lines are parallel by the consecutive interior angles theorem converse. Again, if you need to go back and look at that, rewind and kind of get a better grasp of that, feel free to do so. For class tomorrow, you need to bring me this quiz. So answer these 4 questions off of the which postulates or theorems prove that lines P and R are parallel, based on 4 being congruent to 5, then again based on 2 being congruent to 7, and so on. So using that information, how do you know that P and R are parallel? Bring that to class on next class day, and we will see you then. Have a great day.